So, friends, I have some bad news for all of you today. I should be sitting down. Good, good. Everything dies. That's the bad news. And this question of why do things die? Why do things grow old? Why do things age? This is actually a very interesting question, and today I'm going to talk a little bit about the science. So, just about everything dies, I should say. There are some organisms that seem immortal, that these tend to be very simple organisms, Hydra, certain single-cell organisms. But anything past a certain complexity seems to suffer from aging and death. And there's this observation that bigger animals live longer, smaller animals don't live as long. And you can kind of plot this on a graph, and on average, everything gets about 1 billion heartbeats. And a mouse's heart beats very quickly, and an elephant's heart beats very slowly, but it takes about the same amount of heartbeats to die. Humans are sort of an outlier here. So here's the curve of 1 billion, and humans are up here. So we get 2.5 billion heartbeats. So we're doing better than average, but still we do seem to have an expiration date. Now the good news here is that this is getting better over time. We are approaching longevity escape velocity, but honestly it's been very slow. That most of the gains in lifespan have come from making sure that people don't die very young. And in fact, even in the Middle Ages, I mean, we talk about, oh, people in the Middle Ages had a lifespan of 40 or some number like that, or hunter-gatherers had an average lifespan of 35 in some environments. But most of this was infant mortality, not morality, mortality. And if you, even in a hunter-gatherer frame, if you made it to 50, yeah, you could make it to 70. Or here's a graph of life expectancy at birth, and that's been going up a lot. But life expectancy for a 70-year-old, that's only been going up a little bit. And sort of, we're removing all the big sources of death other than aging, and then increasingly it's aging itself that is killing people. There's also this question of how long people are living and how many years of healthy life they're getting, and there is an increasing disconnect there. It used to be that if you weren't healthy, you would just die. But now we're keeping people around for longer, even if they're not sort of super healthy. So there are some questions that come to mind about the science, and this question of where does aging come from? What even is aging? And I would say that aging is about the failure of our systems to fix themselves. And it's pretty easy to build a system that does a thing, and then it's a little bit more tricky to build a system that can do a thing and fix itself. and then it's even harder to build a system that can do a thing and fix itself, and fix the subsystem that fixes itself, and so on. That you get this cascade of complexity as you build in more and more error correction into the system. And so that's sort of the I would say thermodynamic approach. But my favorite definition of aging comes from Jun Yoon. He's a Silicon Valley venture capitalist, and he has this definition where aging is the loss of homeostatic capacity. And to break that down a little bit, homeostatic capacity, homeostasis is the ability to be in balance, in this case, physiological balance. And then, so your homeostatic capacity is your ability to spring back if your system gets pushed or perturbed in some way. And over time, sadly, this goes down in aging as you grow older. And then it's, in a way, so June uses this analogy of, it's like having a pencil and trying to balance it on your hand. At first, you can sort of adjust it, but then as it gets more wobbly, you have to be a little bit more aggressive in moving your hand, and pretty soon it falls over. Or you can talk about that as if you try and balance a broom in your hand or something. As things get more volatile, things get harder to balance, and the system finally just totally goes out of balance. There are also different theories of aging in terms of maybe we're sort of designed to age and die, or maybe to sort of make room. I don't necessarily put a lot of stock in that, but it is the case that evolution is stronger earlier in life. That evolution cares a lot about whether you survive when you're 5, when you're 10, when you're 15. But when you get up to 70, I mean, past reproductive age, basically, then evolution doesn't really care. And so there's this frame that I do put some stock in, that we don't live very long lives because it's just not something that evolution has selected for. That the people that live many, many years past reproductive age, it didn't matter whether they did or not. It didn't affect how many kids they had, so evolution couldn't select for that. So there's some evidence for this. But, so I would say those are the easy questions. What is aging? How does it work? Is it avoidable or not? Why do we age more in certain past certain points? There are some questions that I would say are harder here. One is, what are so if aging is the buildup of errors, and we'll get to that in a bit, what exactly are the causes of different types of errors? So some errors are caused by our cells dividing and making typos in the new cells that they make. Some errors are frankly caused by cosmic rays that are just passing through, and they slam into some of our DNA, and then it causes a break. And similar with radiation. And yeah, there are a lot of different sort of types of errors and causes of errors, and I'm fascinated by trying to match up these two sets. That can we match the sort of causes of errors with types of errors to understand how different things age us differently. Being out in the sun ages one in a certain way, but not in other ways. So, yeah. Probably the hardest question in this longevity stuff is, how does knowing the science help? Does it help? Is there actionable stuff in longevity science? If you know about telomeres and telomere extension therapy or whatever, if you know about double-stranded DNA breaks, does it help? That's a very important question. So I'm not going to answer that question, but I'm going to talk a little bit about the types of errors that crop up, the types of damage that cause aging. And so Aubrey de Grey absolutely revolutionized aging when he was talking about trying to create an exhaustive list of the things that happen during aging, and then trying to figure out, okay, and he came up with 7, and they are cell loss and tissue atrophy, cancerous cells, mitochondrial mutations, death-resistant cells, extracellular matrix stiffening, extracellular aggregates, and intracellular aggregates. So we can talk about any of the specifics of, okay, what do these crazy words mean? But essentially, 7 types of junk build up in our bodies. And his big idea, Aubrey's big idea, is, hey, if this is really an actual description of what's going on, if these 7 types of junk buildup constitute aging, then if you figured out how to fix each one, you would literally fix aging. So this is a pretty big deal. It's a very strong assertion. I'm not sure he's right, but this is frankly the best game in town in terms of the frame right now. I would also say that we can also talk about what goes wrong in terms of dysregulation. The body has, we can think of the body as consisting of many interlocked thermostats. So a thermostat is you set it to control the temperature, and you can set it a range that if it's above this, lower it. If it's below this, raise it. So you keep in a narrow range. And this is actually the basis for a lot of neuroscience too, that our brain seems to work like this. It's the same thing that allows us to drive down the highway, that our brain is telling us, okay, if this line gets over to the side too much, you're too far over to the side, so make a course correction, and if it happens on the other side, make a course correction. So just stay between these lines. And the systems of the body seem to work like this. And for example, when you take blood tests, you get a normal range, and the body tries to keep your hormones, your attributes inside this range. And this is hard to keep calibrated. There's so many systems interlocking together that over time, just like a scale, a bathroom scale can get miscalibrated, or a temperature thermometer can get miscalibrated, the body gets miscalibrated as well. So that's the frame of dysregulation. And I would say the 3, or I guess this is really 2 types of dysregulation that seem very important. first of all, organ and endocrine dysregulation. So sending the wrong signals to organs in terms of which hormones are getting released, and also your brain can send the wrong signals to your gut, your liver, your kidney, whatever. And actually, and this I believe comes from Jun Yoon as well, or his sort of circle of research, that a lot of organs, a lot of the cases in which we identify as organ failure actually start in the brain. That
Actually starting what?
start in the brain.
Mm-hmm.
That the organ itself is perfectly fine, but the brain sends a wrong signal to the organ and makes it malfunction. And then pretty soon it develops a physical malfunction. But the initial fault is of the brain, the signal. The second sort of cluster of dysregulation is centered on the immune, the immune system. And I would kind of lump in immune system dysregulation and gut flora dysregulation. That so the immune system is not just for fighting colds. It's not just for fighting off bacteria from infections or whatnot. It's actually it has deep hooks into every part of your body, and it's in constant, I would say, dynamic equilibrium with everything else in your environment. So the microbes that live on you and in you, the food that you eat, etc. And so when the environment changes, often when the environment becomes unnatural, then this delicate balance can get disrupted, and then frankly, a lot of bad things can happen, because the immune system does have hooks into everything. I mean, the immune system is partially responsible for pruning connections in the brain. I mean, you don't think of the immune system as influencing the way we think, but it does. So that's sort of what goes wrong from Aubrey's view, from the dysregulation view, and then there are some updates to Aubrey's framework. Turn, they're a cellular therapy company out of Silicon Valley, I believe Silicon Valley. Instead of Aubrey's 7 list of things that go wrong, Turn has 9, but same general approach. So the bad news is that this is very complicated problem. That a lot of things can go wrong on many different levels. And I mean, first of all, things go wrong on the foundational level, on sort of this underlying structure of how the body works. And then that in turn makes things go wrong on the visible level and the levels that we notice. And things go wrong slowly and then more quickly. Just like trying to balance a knife or a pencil or something. At first it tips slowly, but then even more quickly. And unfortunately the body is not made to be fixable. It's made to last, but it wasn't made by sort of some designer that intended it to be able to, you can't bring it into the shop and give it regular overhauls. There are organisms, such as whales, that live a very long time, sometimes much longer than humans. I believe some whales live up to 240 years or or so. But the body is not easily upgradable. We can't just put some whale DNA in our cells and call it good. Maybe we can eventually, but it's not obvious how to do that. So that's sort of the bad news, that this is not an easy problem. So the basic strategy for how to do this, how to approach this, is we find a level of description that allows us to describe what's going on in very clean and simple language. And if we can find sort of this level of description, this way of understanding what the body is doing, how it's doing it, why it's doing it, and then we can understand, okay, errors on this clean, simple level give rise to all the messy problems that crop up in aging. So, big topic here, getting into the theory of abstraction and so on, but in the context of interventions to essentially cure aging, there are three basic approaches here. So the first approach is to find a silver bullet.
Find what?
It's called a silver bullet.
Mm-hmm.
Just find one thing that works super well, that cures everything. And this is generally called the small molecule approach. If we can find this one compound, whether it's a multivitamin, whether it's this NAD+, whether it's some crazy anti-aging injection or something, this is the hope of a lot of people. A few sort of small molecules that people are very interested in here. The first is metformin. I have friends who take this religiously, and I don't know. I don't think that there's a huge amount of data, but at the same time, little downside. So, just to step back to the big picture, this first approach is just finding, one pill that you can take and prolong your life. And I don't think it's a very often it can't hurt, but I don't think it tends to be very effective. So the second approach, I would say, is pioneered by Aubrey, and it's getting rid of the junk. This idea of, okay, if we really are serious about getting to the root of aging and trying to actually fix the problem, actually do things that could actually turn back the clock, then if there is this buildup of junk, then can we just get rid of it? And this is called the senescence approach. And I'm really of two minds here. That there's a lot to be said about this approach. It's relatively fresh. It's clever. I don't know if the list is perfect, and I don't know if the proposed solution for each of these 7 types of buildup is perfect. But the thing that worries me is Aubrey's solution to cancer. So cancer is a very interesting thing in the context of longevity, where most cells are built to self-destruct if they become damaged, and cancer cells don't do that. they somehow turn off that safety valve. And stem cells are often the source of cancer. And stem cells are cells that travel through your body and fix problems. They fix damage. And the observation is that, well, cancer comes when these super flexible cells become damaged and then just start doing their own things, making more of themselves or so on. And the basic approach, as I understand it, is to not let our body have stem cells. And this seems, first of all, kind of a clever approach to the problem of cancer. But second of all, it feels that I feel deep ambiguity in terms of giving up my stem cells, my ability to actually fix damage, and making my health dependent on sort of regular visits to the doctor to fix the damage now that my stem cells are taken out or dead or deactivated. So the first kind of core strategy with fixing aging is finding a pill to do it. And I shared with you why I thought maybe that's not such an effective strategy. And the second approach to fixing aging is to basically do it manually, that figure out, okay, what kinds of things build up and how do we go in and sort of manually fix these things. And there's, Aubrey's list of 7 and Turn.bio's list of 9 and whatnot. But I'm a fan of this third frame that inject signal to drown out the noise. So a lot of what goes wrong in aging is the system gets more noisy. That there's, over time, the signal, the order in the system weakens, it breaks down, and then there's just more chaos and entropy about what's going on. Cells running around not knowing what to do and getting bad info from other cells, and it's a mess. And especially in cancer. And so this approach basically says, okay, maybe if we find a way to boost the signal back up to original levels or even further, maybe we can get a lot of effects through fairly simple interventions. I think of it as the body is like an orchestra playing this wonderful symphony, and over time instruments will just go flat. That's just the nature of instruments. That
doesn't mean flat.
Oh, so instead of playing a clear note,
okay.
it goes yeah.
Okay, I understand what you mean. But she will not.
And the more instruments that go flat, the harder all the other instruments have it to play the right note.
Okay.
And so basically, if you can find a way to inject that original note back in to the system, it'll help all the instruments play well. So there aren't a huge number of ways to do this yet, but on day 3, I'll be talking about genetic spell check, which is it's very near and dear to my heart, and I think it'll be a very effective way to do this. So it's not real yet, it doesn't exist yet, but it could in maybe 10 years. So we'll discuss that. This has been the talk of bad news. Everybody dies, everything dies, and it's a hard problem. It's not going to get fixed overnight. And people are working on it, but it's not something that we have solutions for right now. We can't go to the hospital and sign up for SENS. We can't go to the hospital and sign up for genetic spell check. There are pills, but there aren't any silver bullets. Now, my third talk is going to be a lot more hopeful. It's going to be about future developments and technology. But I just want to bring it home to some practical implications today. And the first implication is things cascade. That if you're struggling with things, it's really worth fixing, because stress put on one part of the system will ripple out to other parts of the system. So it's really worth fixing problems if you notice them. So I mentioned inflammation, digestive issues, hormone imbalances, and if you kind of know in the back of your head something is going on here, it's really worth fixing sooner rather than later. And the last point here is that most things are way more fixable than we realize. That I think that a lot of times the medical establishment has sort of given up on certain problems. They say, well, that's just a thing that a lot of people suffer from, and here's what generally happens, and I guess too bad, tough luck, here's your future all mapped out. But I think that it's really worth getting, like, if you are struggling with something, doing very deep research and just trying things, see what works for you. This can fix a lot more problems than people realize. So, not very specific advice here, but just, yeah, don't give up. So, that's it.